When the galaxy's most advanced civilizations discovered a planet where temperatures could plummet to absolute zero in minutes, and then sort of molten hellfire in seconds, they called it impossible to survive. The Zephyrians, masters of atmospheric control, fled after losing 3 research teams. The crystalline Nexari, who had thrived in the harshest environments for millennia, abandoned their equipment and evacuated within hours. Even the cybernetic Vorthak, with their mechanical precision and adaptability, declared the world a planetary anomaly incompatible with life. But humans? Humans looked at this frozen inferno and said, "Hold my coffee." What happened next would redefine what the galaxy thought they knew about the stubborn, creative, and utterly unpredictable species from Earth. In a test that would push human ingenuity to its absolute limits, they would prove that sometimes the most impossible challenges require the most human solutions. This is the story of how humanity turned hell itself into home. The warning signals from planet Thermos 7 have been broadcasting across the galaxy for 3 standard years. Every major civilization had tried to establish a research outpost on the bizarre world, and every single one had failed catastrophically. The planet's surface shifted between temperatures of minus 273 degrees Celsius and plus 2,000 degrees Celsius within minutes, creating an environment so hostile that even the most advanced alien technologies couldn't adapt fast enough to survive. Captain Sarah Chun stood in the observation deck of the human research vessel Persistence, watching the swirling chaos of Thermos 7 through reinforced viewports. Ice storms raged across one hemisphere, while volcanic eruptions painted the other in streams of molten rock. The planet rotated slowly, bringing each region through cycles of absolute cold and scorching heat every 6 hours. "Captain, incoming transmission from the Galactic Research Council," announced Lieutenant Marcus Rivera from the communications station. His voice carried a hint of amusement that he was trying to suppress. "Put it through, Marcus." The holographic display shimmered to life, revealing the elongated blue form of Coordinator Veltar, a Zephyrian diplomat whose species had been the first to attempt colonization of Thermos 7. The alien's gill slits fluttered nervously as he spoke. "Captain Shun, the Council has reviewed your application to establish a research station on Thermos 7. While we admire human determination, we must strongly advise against this venture. 3 of our finest atmospheric specialists perished when their environmental suits failed during a temperature transition. The Nexari lost an entire geological survey team when their crystalline protection matrices shattered. Even the Vorthak cyber-enhanced explorers couldn't adapt their systems fast enough." Sarah smiled politely, her dark eyes reflecting the chaotic light patterns from the planet below. At 42, she had spent most of her career dealing with alien bureaucrats who underestimated human capabilities. Her graying hair was pulled back in a practical ponytail, and her weathered hands showed the scars of previous missions where humans had succeeded where others had failed. "Coordinator Veltar, we appreciate your concern. However, humans have a different approach to environmental challenges. We don't just adapt to extreme conditions. We engineer our way through them." The Zephyrian's head crest rose in what Sarah recognized as confusion. "Captain, with respect, your species' technology is not as advanced as ours. Your ships are slower, your computers less sophisticated, your materials science decades behind our own. How do you propose to succeed where we have failed?" Dr. Elena Vasquez, the mission's chief engineer, stepped forward. Her compact frame belied the fierce intelligence behind her brown eyes. Years of working in the outer colonies had taught her that sometimes the simplest solutions were the most effective. "Coordinator, may I ask what approach your teams used on Thermos 7? Veltar's display switched to show detailed schematics. "Our atmospheric specialists wore advanced environmental suits with rapid adaptation protocols. The suits were designed to automatically adjust internal temperature and pressure to match external conditions within nanoseconds. Elena nodded dojehashfully. And when the temperature dropped from 1,800 degrees to minus 270 degrees in 30 seconds, the adaptation systems overloaded. The rapid temperature change exceeded the suit's processing capacity, and the environmental controls failed." "I see. And the Nexari approach?" A new voice joined the transmission as crystalline entity Zexan materialized in the hologram. The Nexari's body was composed of living crystal that normally allowed them to survive in extreme environments by adjusting their molecular structure. Our geological teams used resonance-based protective matrices. Zexon explained, their voice creating harmonic frequencies that translated through the communication system. The matrices create stable microenvironments by vibrating at frequencies that maintain optimal temperature and pressure conditions. Elena raised an eyebrow, and when the ground temperature shifted, the resonance frequencies required constant adjustment. During rapid temperature transitions, the harmonic calculations became too complex. The matrices couldn't maintain stable frequencies, and they shattered from harmonic discord. Dr. James Nakamura, the team's material scientist, leaned forward with interest. His Japanese heritage showed in his precise movements and careful attention to detail. What about the Vort-Hack cyber enhancement approach? The display shifted again to show Commander Zixhal, a cybernetic being whose body was a fusion of organic tissue and advanced machinery. Red optical sensors glowed where eyes might have been on a fully organic being. Our enhanced explorers utilize adaptive cybernetic systems, Zixhal stated in a mechanical voice. Internal heating and cooling elements adjust body temperature in real time, while reinforced skeletal structures provide protection against environmental stress. James scratched his chin thoughtfully. Response time. Our systems can adapt to temperature changes within 0.3 seconds. Not fast enough for 30-second transitions, I'm guessing. Zixhal's optical sensors dimmed slightly. Correct. The thermal stress exceeded our adaptive capacity. 3 explorers suffered catastrophic system failures when their cooling systems couldn't compensate for the rapid temperature increases. Sarah looked around at her team, noting the growing excitement in their expressions. She knew that look. It was the same expression humans got when someone told them something was impossible. Coordinator Veltar, we thank you for sharing your experiences. They'll be very helpful in developing our approach. Captain Chun, Veltar's crest flattened in what Sarah recognized as concern. Surely you're not suggesting you can succeed where 3 of the galaxy's most advanced civilizations have failed? Actually, that's exactly what I'm suggesting. Sarah's grin widened. Dr. Vasquez, would you like to explain our strategy? Elena stepped forward, her eyes bright with enthusiasm. The problem all your teams encountered was trying to adapt to the environment in real time. You were fighting the planet's natural cycles instead of working with them. Explain. Zexon's crystalline form shifted colors, indicating curiosity. Instead of trying to create technology that can instantly adapt to extreme temperature changes, we're going to build a base that doesn't need to adapt. We're creating a thermal buffer zone. Rapidly. A thermal buffer? The energy requirements would be astronomical. James Nakamura activated his own holographic display, showing detailed engineering schematics. Not if you design it correctly. We're not trying to heat or cool the entire environment. We're creating a stable thermal core using a combination of geothermal taps and radiative heat exchangers. The alien representatives leaned forward, studying the human designs with growing interest. The base will be constructed underground, Elena continued, with the living areas situated between natural thermal regulators. When the surface temperature drops, our geothermal systems provide heat. When it rises, our heat exchangers and thermal mass systems absorb and dissipate the excess energy. The genius is in the simplicity, added Dr. Sarah Kim, the mission's environmental specialist. Her Korean ancestry had given her a deep appreciation for efficient design principles. We're not fighting the planet's thermal cycles. We're using them to our advantage. Commander Zixhal processed this information with mechanical precision. Your approach lacks the sophisticated real-time adaptation protocols that advanced civilizations require. How do you account for unexpected thermal variations? Sarah couldn't help but laugh. Commander, that's exactly the point. We don't need sophisticated adaptation protocols because we're not trying to adapt. We're creating a stable environment that doesn't change regardless of external conditions. Dr. Michael O'Brien, the team's geologist, spread out surface scans of Thermos 7 on his workstation. His Irish accent thickened with excitement as he pointed to specific geological features. The planet's thermal cycles are actually quite predictable once you understand the underlying geology. The extreme cold periods occur when the planet's rotation brings regions away from geothermal vents. The extreme heat comes from direct exposure to those same vents and solar radiation. The key insight, Elena added, is that the thermal energy doesn't disappear during cold cycles. It just moves underground. If we tap into the right geological layers, we can access consistent geothermal energy regardless of surface conditions. Veltar's display flickered as he consulted with off-screen advisors. When he returned, his expression was skeptical. Captain Shun, your approach seems overly simplistic. Surely you're overlooking critical variables that would affect long-term habitability. Actually, we've run extensive simulations, Dr. Kim replied, activating her environmental modeling system. The human approach to extreme environment survival focuses on creating islands of stability rather than constantly adapting to change. The holographic display showed detailed models of the proposed base, with thermal flow patterns, structural stress analyses, and long-term habitability projections. Our simulations show that a properly designed thermal buffer system can maintain stable internal temperatures of 20 degrees Celsius plus or minus 2 degrees, regardless of external temperature variations, Kim explained. Zexen's crystal body resonated with harmonic frequencies that translated as amazement. These calculations assume perfect thermal isolation. Such precision requires materials that don't exist. James smiled knowingly. Actually, they do exist. Humans have been developing advanced insulation materials for centuries. We call them aerogel composites and vacuum panel systems. Nothing fancy by galactic standards, but incredibly effective for thermal management. But the construction challenges Zixhull protested. How do you propose to build underground structures while surface temperatures fluctuate so dramatically? Remote construction drones, Elena replied simply. We build the facility in sections during stable thermal periods, using automated systems that don't require life support. And if the drones fail due to thermal stress? Veltar asked. We build more drones, Sarah answered matter-of-factly. Human engineering philosophy is pretty straightforward. If something breaks, you fix it or build a replacement. We don't expect perfection from our technology because we know how to adapt when it fails. The three alien representatives conferred among themselves for several minutes. When they returned, their expressions showed a mixture of skepticism and fascination. Captain Shun, Veltar spoke for the group. The Galactic Research Council cannot officially endorse this mission, given the extreme risk involved. However, we will not prevent you from attempting it. We appreciate your understanding, Coordinator. However, Zexen interjected, we request permission to monitor your progress. Your approach to extreme environment survival is unconventional by galactic standards. Granted, with the understanding that this is a human-led mission. We welcome observers, but our methods may seem strange to species accustomed to more advanced technologies. After the transmission ended, Sarah turned to address her crew. The observation deck buzzed with excited conversations as team members discussed the technical challenges ahead. All right, people. We've got 6 months to build a base that can survive conditions that have killed representatives from 3 major galactic civilizations. Anyone having second thoughts? Dr. Vasquez raised her hand with a grin. Captain, I've got a question. Go ahead, Elena. Can we make the base big enough for a proper workshop? I've got some ideas for improvements to our thermal management systems once we're down there. The crew erupted in laughter. Sarah nodded approvingly. That was the human spirit that made these impossible missions possible. Elena, we'll make sure you've got the best workshop on Thermos 7. Probably the only workshop on Thermos 7, but definitely the best. As the Persistence moved into orbit around the chaotic planet below, Sarah watched ice storms rage across continents that would be molten wastelands in just a few hours. She thought about the alien representatives' confusion at the human approach to the problem. They saw Thermos 7 as an impossible challenge requiring impossible technology. Humans saw it as Tuesday. The difference, Sarah reflected, wasn't in their technology or their intelligence. It was in their fundamental approach to problems. Other species try to create perfect solutions that could handle every possible variable. Humans created good enough solutions and then figured out how to fix them when they inevitably broke down. Dr. O'Brien joined her at the viewport, his geological survey tablet displaying real-time thermal readings from the planet's surface. Captain, I've been analyzing the thermal cycle patterns. There's something interesting about the geological structure that I think the other species missed. What's that, Michael? The planet isn't chaotic at all. It's actually incredibly stable, just not in the way most species expect. The thermal cycles follow precise geological rhythms based on the planet's rotation and internal structure. Once you map those rhythms, the environment becomes predictable. Sarah nodded thoughtfully. So while everyone else was trying to build technology that could react to chaos, we're building a base that can predict and work with the planet's natural patterns. Exactly. It's like the difference between trying to surf a tsunami and learning to read the ocean. Other species see chaos where we see patterns. Dr. Kim approached with her environmental analysis complete. Captain, I've finished the atmospheric modeling for the base location. The underground thermal stability is even better than our initial projections indicated. How much better? We should be able to maintain habitable conditions with 40% less energy input than originally calculated. The planet's geological structure is actually helping us create thermal stability. Elena overheard the conversation and joined the group at the viewport. That's consistent with what James and I discovered about the material science. The extreme temperature variations on the surface have created some unique mineral formations that we can use for enhanced insulation. Meaning, Sarah prompted, meaning we can literally mine insulation materials from the planet itself. The thermal stress has created crystal matrices that are better insulators than anything we brought with us. Sarah felt the familiar surge of pride in her species that came with watching humans turn impossible challenges into engineering opportunities. While other civilizations had seen Thermos 7 as a hostile environment to be overcome, her team was already identifying ways to make the planet work for them rather than against them. All right, team, let's get started. We've got a base to build and some aliens to educate about human engineering philosophy. As the crew dispersed to begin their preparations, Sarah remained at the viewport. Below them, Thermos 7 continued its relentless cycle of freezing and burning, a planetary testament to the power of extreme conditions. But Sarah no longer saw a hostile world. She saw humanity's next home away from home. The real test was about to begin. 3 weeks into construction, the first major crisis hit when Thermos 7 decided to throw them a curveball that wasn't in any of their geological surveys. Sarah Chan stood in the temporary command center aboard the Persistence, watching her construction drones work frantically against time. The surface temperature readings showed they had approximately 40 minutes before the current thermal zone would shift from its stable 15 degrees Celsius window to either flash freezing cold or molten hellfire, depending on which direction the planetary thermal currents decided to flow. Captain, we've got a problem. Dr. O'Brien's voice crackled through the communication system from the surface monitoring station. His Irish accent was thicker than usual, which meant he was either excited or worried. Given the circumstances, Sarah suspected it was the latter. What kind of problem, Michael? Remember how I said the planet's thermal cycles were predictable? Well, I was right about that. The problem is, I was wrong about the timescale. Sarah felt her stomach drop. Explain. The geological surveys from the alien expeditions were accurate for short-term patterns. 6-hour cycles, predictable rotation effects, stable geothermal activity. What they missed was that Thermos 7 has longer-term thermal variations that operate on a different timescale. Dr. Elena Vasquez looked up from her engineering console, where she had been monitoring the progress of their underground excavation. How different? Tri-monthly cycles, Michael replied grimly. We're about to experience what I'm calling a thermal inversion event. Instead of the normal temperature variations, the entire planet is going to essentially flip its thermal profile for the next 72 hours. Meaning what exactly? Sarah asked, though she suspected she wasn't going to like the answer. Dr. Kim's voice joined the conversation from her environmental monitoring station. I'm reading massive atmospheric pressure changes planet-wide. The areas that normally experience extreme cold are showing rapid temperature increases, and the hot zones are beginning to cool dramatically. James Nakamura whistled softly from his materials analysis station. No wonder the alien expeditions failed. Their short-term surveys wouldn't have detected monthly variations. They designed their equipment for the normal thermal cycles. How bad is this for our construction timeline? Sarah asked Elena. Elena was already running calculations on her engineering display. Bad. Our construction drones are designed to handle the standard 6-hour cycles. A 72-hour thermal inversion means our safe construction windows are about to disappear completely. Can we pull the drones back until the inversion passes? Not without losing 3 weeks of progress. We've got the foundation excavation 60% complete, and the thermal regulation systems are partially installed. If we abandon the site now, the thermal inversion will destroy everything we've built. Sarah studied the tactical display showing their construction site. Red warning indicators were beginning to appear as surface temperatures started their dramatic shift. According to the readings, they had maybe 30 minutes before the area became completely uninhabitable. Options, people. Give me options. Dr. Marcus Rivera spoke up from the communication station. Captain, I'm receiving a transmission from the Galactic Research Council. Coordinator Veltar is requesting immediate evacuation assistance. Put him through. The holographic display activated, revealing Veltar's blue form. His gill slits were fluttering rapidly with obvious distress. Captain Shun, our orbital sensors are detecting massive planetary thermal instability. You must evacuate your surface teams immediately. This level of environmental chaos will overwhelm any survival systems. Thanks for the warning, Coordinator. We're tracking the thermal inversion. Veltar's head crest rose in surprise. You knew about this phenomenon. We're learning about it in real time, Sarah admitted. Our geologists just identified the pattern. It appears to be a monthly cycle that your expeditions didn't encounter during their brief survey periods. Captain, this proves that Thermos 7 is even more dangerous than we calculated. Surely you must see that establishing a permanent base is impossible. Elena stepped into the hologram's field of view. Actually, Coordinator, this makes our thermal buffer approach even more viable. Veltar's confusion was obvious. How do you reach that conclusion? The environmental chaos is exponentially worse than our worst-case scenarios. Because, Elena replied with growing excitement, our thermal buffer system doesn't depend on surface conditions. If anything, more extreme temperature variations give us more thermal energy to work with. Dr. Kim joined the conversation. Coordinator, your species' approach was to adapt to the environment. Thermal inversions are catastrophic for adaptive systems because they exceed the parameters you designed for. Our approach doesn't adapt, it insulates. But surely the increased thermal stress will overwhelm your insulation systems? James activated his materials analysis display. Actually, no. Our thermal buffer calculations were based on worst-case temperature differentials. The thermal inversion doesn't exceed our design parameters. It just sustains extreme differentials for longer periods. Veltar was quiet for several moments as he processed this information. You designed your systems to handle conditions worse than what actually exist. Standard human engineering practice, Sarah explained. We call it over-engineering. We design for conditions twice as bad as we expect to encounter because we know our initial estimates are usually wrong. This seems inefficient. Elena loves it. Coordinator, efficiency is getting the job done. Everything else is just optimization. After ending the transmission with Veltar, Sarah turned her attention back to the immediate crisis. The construction drones had less than 20 minutes of stable working time before the thermal inversion hit their location. Elena, can we accelerate the construction timeline? Not safely. The thermal regulation system installation requires precise calibration. If we rush it, we'll end up with a base that can't maintain stable internal temperatures. What if we don't try to finish everything before the inversion hits? Dr. O'Brien suggested. What if we design the construction process to work with the thermal inversion instead of against it? Sarah looked at him with interest. Explain. The thermal inversion is going to create massive temperature differentials across the planet. Instead of fighting those differentials, what if we use them to power our construction process? Elena's eyes widened as she grasped the implications. Thermoelectric generation. We could use the temperature differences to generate massive amounts of electrical power. Enough power to run construction operations during periods when it would normally be impossible, James added, his excitement growing. Dr. Kim was already running environmental calculations. The power generation potential during thermal inversion events would be enormous. We're talking about temperature differentials of over 2,000 degrees Celsius across relatively short distances. How quickly can we modify our construction approach? Sarah asked. Elena was furiously typing commands into her engineering console. I can reprogram the construction drones to deploy thermoelectric generators as part of their primary objectives. Instead of just building thermal regulation systems, they'll build power generation systems that happen to regulate temperature as a side effect. Do it. Captain, Mark is called from communications. I'm receiving multiple transmissions from alien observer vessels. The Nexari, Zephyrians, and Vorthak all have ships monitoring our progress. What are they saying? They're confused. The Nexari vessel is requesting clarification on why we haven't evacuated. The Zephyrian ship is asking if we understand the scope of the environmental crisis. The Vorthak are demanding to know what emergency protocols we're implementing. Sarah grinned. Tell them we're implementing Protocol Human 1. What's Protocol Human 1, Captain? When things get worse, we get more creative. As the thermal inversion began to take hold, the surface readings from Thermos 7 showed chaos that would have been terrifying to any sane species. Temperature differentials that normally took hours to develop were occurring in minutes. Atmospheric pressure was fluctuating wildly. Geological stress readings indicated minor seismic activity as the planet's crust adjusted to the thermal changes. The human construction drones, however, were thriving. Elena's modifications had transformed them from simple excavation and construction units into mobile power plants. As the thermal inversion created massive temperature differentials, the drones deployed thermoelectric generators that converted the temperature differences directly into electrical energy. Power generation is at 300% of normal capacity, Elena reported with obvious satisfaction. The thermal inversion is giving us more construction energy than we've ever had available. Construction progress? Sarah asked. Accelerating. With the additional power available, we can run multiple construction operations simultaneously. Foundation excavation is now 85% complete, thermal regulation system installation is at 40%, and we've started early deployment of the habitat modules. Dr. O'Brien was monitoring geological sensors from the construction site. Captain, the thermal inversion is creating some interesting geological effects. The rapid temperature changes are causing expansion and contraction in the rock layers that's actually helping with our excavation. Helping how? Natural fracturing along optimal excavation lines. The thermal stress is breaking apart rock formations in exactly the patterns we need for foundation construction. It's like the planet is excavating itself for us. James was studying material samples collected by the construction drones. The thermal inversion is also creating new mineral formations that we can use for enhanced insulation. Rapid temperature cycling is forcing crystal realignments in ways that improve thermal resistance properties. Dr. Kim looked up from her environmental monitors with amazement. Atmospheric composition is stabilizing as well. The extreme temperature variations are driving convection patterns that are actually evening out atmospheric pressure variations. Sarah studied the tactical display, watching red warning indicators gradually shift to yellow caution markers and then to green operational status. Are you telling me that the thing that drove 3 alien species away from this planet is actually making it easier for us to build our base? That's exactly what I'm telling you, Elena replied. The thermal inversion isn't a crisis for our construction approach. It's a massive energy source that we can harness for accelerated development. The communication console lit up with incoming transmissions from the observing alien vessels. Sarah had Marcus put them all through on a group channel. Coordinator Veltar appeared first, his gill slits fluttering with confusion. Captain Shun, our sensors indicate that your construction operations are accelerating during the thermal inversion. This seems impossible. Crystalline entity Zexin materialized next, their body displaying color patterns indicating extreme bewilderment. Human vessel persistence. Our geological analysis suggests that planetary conditions are beyond the survival threshold for any known species. Yet your surface operations appear to be thriving. Commander Zixhol's mechanical voice joined the conversation. Captain Shun, our tactical analysis indicates that you're using the thermal inversion event as an energy source for enhanced construction capabilities. Please confirm this reading. Confirmed, Commander. The thermal inversion is providing us with more construction energy than we originally planned for. This contradicts all established protocols for extreme environment survival, Zixhol stated flatly. Elena stepped forward with a grin. Commander, that's because you're thinking of the thermal inversion as a problem to be solved instead of a resource to be utilized. Veltar's confusion was evident. How do you conceptualize a lethal environmental phenomenon as a resource? Easy, Elena replied. Extreme temperature differentials contain enormous amounts of thermal energy. Instead of fighting that energy, we capture it and convert it into useful work. Zexin's crystal body resonated with harmonic frequencies. This approach requires technology that doesn't exist. Efficient thermoelectric conversion at these temperature extremes should be impossible with your level of materials science. James activated his material analysis display. Actually, it's not about efficient conversion. It's about useful conversion. We don't need perfect efficiency. We just need enough power generation to support our construction operations. But the thermal stress on your conversion systems, Veltar protested. The equipment failure rates must be catastrophic. They are, Sarah admitted cheerfully. We lose about 30% of our thermoelectric generators during each thermal cycle. So we build replacements. Build replacements? Zixhol's mechanical precision couldn't hide his confusion. The material costs must be prohibitive. Elena Lauzet. Commander, we're literally building replacement parts for materials we mine on the planet itself. The thermal inversion creates the mineral formations we need for thermoelectric generation. It's a self-sustaining system. You're saying the planet provides the materials to build the technology that harnesses the planet's energy? Zexon asked. Exactly. The thermal cycling creates crystal formations with useful thermoelectric properties. We mine those crystals, manufacture basic thermoelectric generators, and use the generated power to run more mining and manufacturing operations. Veltar was quiet for several moments. Captain Shun, this approach seems remarkably primitive. Thank you, Sarah replied sincerely. Primitive approaches tend to be robust and reliable. We don't need sophisticated technology that works perfectly under ideal conditions. We need simple technology that works adequately under terrible conditions. But surely there are limits to this approach? Zixol pressed. What happens when your simple systems encounter conditions beyond their design parameters? They break, Elena answered matter-of-factly. And then we fix them or build new ones. Human technology is designed to be repaired and replaced, not to be perfect. Dr. O'Brien joined the conversation from the surface monitoring station. The beauty of a human approach is that it doesn't depend on everything working perfectly. Our base design assumes that half our systems will fail at any given time. How do you maintain operational capability with such high failure rates? Zexon asked. Redundante, Doctor, Kim replied. We build multiple systems that perform the same function. If half of them fail, the other half keep working. And we design systems that can be easily repaired or replaced with basic tools and materials, James added. Everything in our base can be fixed by someone with a wrench and some spare parts. The alien observers processed this information in their respective ways. Veltar's gill slits fluttered thoughtfully. Zexon's crystal form shifted through contemplative color patterns, and Zixhol's optical sensors dimmed as he ran calculations. Finally, Veltar spoke for the group. Captain Shun, your approach to extreme environment survival is unlike anything in our databases. We request permission to observe the remainder of your construction project. Granted, with the understanding that our methods may continue to seem strange by galactic standards. Captain, Zixhol added, one final question. What do you call this approach to engineering? Sarah looked around at her crew, all of whom were grinning with the satisfaction of turning an impossible crisis into a construction advantage. We call it Thursday, Commander. Just another Thursday. As the thermal inversion continued to rage across Thermos 7's surface, the human construction operations not only continued, but actually accelerated. The alien observers watched in fascination as humanity demonstrated once again that their greatest strength wasn't in having the best technology. It was in making any technology work under any conditions. The real lesson of Thermos 7 was just beginning to unfold. 6 weeks into construction, Thermos 7 decided to test human ingenuity in ways that no geological survey could have predicted. Captain Sarah Chun stood in what would eventually become the main habitat module of Thermos Base Alpha, humanity's first permanent installation on the frozen Inferno planet. The underground facility was 70% complete, with thermal regulation systems maintaining a comfortable 22 degrees Celsius, while surface temperatures fluctuated between minus 250 and plus 1,800 degrees. The base itself had become something of a marvel. Instead of the sleek, sophisticated structures favored by advanced alien civilizations, Thermos Base Alpha looked like what it was, a triumph of practical engineering over elegant design. Thick insulation barriers surrounded every habitat module. Redundant thermal management systems snaked through corridors like mechanical vines. Emergency repair stations were positioned every 20 meters, stocked with spare parts and basic tools. To alien observers, it looked primitive. To humans, it looked like home. Captain, Dr. Elena Vasquez called from the engineering section, her voice carrying a note of concern that immediately got Sarah's attention. We need to talk. Sarah made her way through the bustling construction zone, past crews of engineers installing atmosphere processors and technicians calibrating thermal sensors. The base hummed with activity as dozens of specialists worked to complete humanity's most ambitious extreme environment project. She found Elena in the central engineering bay, surrounded by holographic displays showing real-time planetary conditions. The engineer's usual confident demeanor had been replaced by something Sarah had rarely seen: uncertainty. "What's the problem, Elena?" "It's not exactly a problem," Elena replied, manipulating the holographic controls to show planetary thermal readings. "It's more like an opportunity that's about to become a crisis if we don't handle it right." Dr. Michael O'Brien looked up from his geological analysis station, his Irish accent thick with excitement. "Captain, remember how I identified the monthly thermal inversion cycles? Well, it turns out they're part of an even larger pattern." Sarah felt familiar stirring of anticipation mixed with apprehension. In her experience, when scientists got excited about discovering larger patterns, it usually meant someone's day was about to become much more complicated. "How much larger?" "Try yearly," Michael replied, activating a comprehensive geological display. Thermos 7 has annual thermal events that make the monthly inversions look like minor temperature fluctuations. The holographic display showed a massive three-dimensional model of the planet, with thermal flow patterns mapped across its entire surface. Sarah studied the data, trying to understand what she was looking at. "The planet essentially undergoes complete thermal restructuring once per year," Dr. Sarah Kim explained, joining the group around the display. "The entire geological system shifts into what I can only describe as a planetary fever." "Define planetary fever," Sarah requested. James Nakamura pulled up material analysis charts, showing temperature projections that made Sarah blink twice to make sure she was reading them correctly. Surface temperatures reaching 5,000 degrees Celsius in hot zones, and dropping to near absolute zero in cold zones. But that's not the worst part. There's a worse part. Elena highlighted specific areas on the planetary model. The thermal differential creates massive atmospheric convection. We're talking about hurricane force winds carrying superheated or supercooled air masses across continents. Weather patterns that would make Jupiter's storms look like gentle breezes. Dr. Kim added more environmental data to the display. Atmospheric pressure variations of over 400%, seismic activity from thermal expansion and contraction, and electromagnetic effect from the massive heat transfer that will interfere with most electronic systems. Sarah studied the projections, noting that the annual thermal event was scheduled to begin in approximately 8 weeks. "How long does this planetary fever last?" 2 weeks, Michael replied. 2 weeks of conditions that would be catastrophic for any species that tried to survive them using conventional approaches. But Elena added with a grin that Sarah recognized as her "I got an idea" expression, potentially beneficial for species crazy enough to build thermal engineering systems designed to harness extreme energy sources. "Explain." James activated his materials analysis systems. "Captain, the thermal energy available during the planetary fever is enormous. We're talking about power generation potential that exceeds anything in human space by several orders of magnitude." "Enough power to do what?" Elena's excitement was becoming infectious. "Enough power to complete our base construction in a matter of days instead of months. Enough power to begin manufacturing operations that could supply other human colonies throughout the sector. Enough power to demonstrate that humans can not only survive in impossible environments, but actually thrive in them." Dr. O'Brien was already running geological simulations. The seismic activity during the fever will expose new mineral deposits. Rare elements that normally require deep mining operations will be accessible through surface collection. The atmospheric convection will distribute essential elements across the planet in unprecedented concentrations, Dr. Kim added. "We could establish mining operations that wouldn't be possible under normal conditions." Sarah looked around at her team, noting the growing excitement in their expressions. She had seen this before, humans getting enthusiastic about turning impossible challenges into opportunities for advancement. "All right, people, what's the catch? This sounds too good to be true." Elena's expression became more serious. "The catch is that we need to completely redesign our base systems in 8 weeks. The planetary fever will generate so much thermal energy that our current thermal management systems will be overwhelmed." "Overwhelmed how?" "Think of it like this," James explained. "Our current systems are designed to handle a campfire. The planetary fever is going to give us the thermal equivalent of a nuclear reactor. Can we scale up our existing systems?" "Not with conventional approaches," Elena replied. but I've been working on some ideas that might work. She activated a new set of engineering schematics that showed the base design modified with additional thermal management systems that looked unlike anything Sarah had seen before. What am I looking at? Thermal siphon networks, Elena explained enthusiastically. Instead of trying to insulate ourselves from the planetary fever, we embrace it. We turn our base into a massive thermal processing facility that captures the thermal energy and converts it into useful power. Dr. Kim was studying the environmental impact projections. The thermal siphon approach would actually help stabilize planetary conditions during the fever. We'd be functioning as a thermal regulator for the entire region. You're saying our base would help calm down the planetary fever? Exactly. By providing thermal relief valves for the excessive energy, we'd reduce the severity of local weather patterns. Instead of fighting the planet, we'd be helping it. The communication console activated, indicating an incoming transmission from their alien observers. Sarah had Marcus put it through on the main display. The hologram shimmered to life, revealing not just Coordinator Veltar, but representatives from all three observing civilizations, along with several new faces that Sarah didn't recognize. Captain Chun, Veltar began, his gill slits fluttering with obvious agitation. Our long-range sensors have detected signs of an approaching planetary thermal catastrophe. You must evacuate immediately. We're aware of the annual thermal event, Coordinator. Our geological team identified the pattern several hours ago. A new voice joined the conversation as Ambassador Klexton materialized in hologram. The tall, ethereal being species was unknown to Sarah, but their obvious authority suggested they were high-ranking representatives from the Galactic Research Council. Captain Chun, I am Ambassador Klexton, representing the Emergency Response Division of the Galactic Research Council. The thermal event approaching Thermos 7 exceeds all known parameters for planetary habitability. We are prepared to provide immediate evacuation assistance for your personnel. We appreciate the offer, Ambassador, but we're planning to remain on-site during the thermal event. The reaction from the alien representatives was immediate and dramatic. Veltar's head crest rose to its maximum height. Zexon's crystal body flashed warning colors, and several new representatives began speaking simultaneously in their respective languages. Ambassador Klex then raised a graceful hand to restore order. Captain Chun, perhaps you don't understand the scope of this phenomenon. The thermal event will generate conditions equivalent to stellar surface temperatures in some areas, while creating near absolute zero conditions in others. No known species has ever survived such extreme environmental chaos. Elena stepped forward with her characteristic confidence. Ambassador, that's because no known species has ever tried to harness such extreme environmental chaos. Explain. Instead of trying to survive the thermal event, we're going to use it, Elena replied, activating the thermal siphon schematics for the alien representatives to examine. The extreme thermal energy represents an unprecedented power source that we can capture and direct. Crystalline Entity Zexon studied the schematics with growing amazement. These designs suggest using the entire planet as a power generation system. Such an approach requires engineering precision beyond current galactic capabilities. James joined the conversation. Actually, it requires engineering in precision. Our systems are designed to work when everything goes wrong. Elaborate. Commander Zixhull requested. Galactic engineering focuses on creating systems that work perfectly under controlled conditions, James explained. Human engineering focuses on creating systems that work adequately under any conditions. The thermal siphon networks don't require precise control or perfect efficiency, Elena added. They just need to move thermal energy from areas with too much to areas with too little. Even if half the systems fail, the remaining half will still function. Ambassador Klex then was studying the base design with obvious fascination. Captain Chun, this approach is unlike anything in our databases. You're essentially proposing to integrate your habitat with the planet's thermal system. That's exactly what we're proposing, Sarah confirmed. Instead of fighting Thermos 7's thermal cycles, we're going to become part of them. A new voice joined the conversation as High Engineer Vexmore appeared in the hologram. The Nexury's crystalline form was displaying color patterns that Sarah's translation system identified as extreme technical interest. Human engineers, Vexmore's harmonic voice resonated through the communication system. Your proposed thermal siphon networks would require unprecedented amounts of construction material. The logistical challenges alone would exceed the capabilities of most civilizations. Elena Grinet. Hi, engineer. We're planning to manufacture most of our materials on-site using thermal energy from the planetary fever. Impossible. Manufacturing operations require stable environmental conditions and precise temperature control. Not if you design your manufacturing systems to work with unstable environmental conditions and imprecise temperature control, James replied. We call it thermal forging. We use the extreme temperatures to process raw materials into useful components. Dr. O'Brien activated his geological surveys. The planetary fever will expose massive amounts of raw materials that we can collect and process. Instead of importing manufactured goods, we'll manufacture everything we need using the thermal energy that other species see as a catastrophe. You're saying the planetary fever will provide both the power source and the raw materials for your expansion operations? Bexmore asked. Exactly, Sarah confirmed. By the time the thermal event ends, we'll have a fully operational base, expanded manufacturing capabilities, and enough processed materials to begin large-scale operations. Ambassador Klex then was quiet for several moments as they processed this information. When they spoke again, their voice carried a note of amazement. Captain Shun, if your approach succeeds, it would revolutionize extreme environment colonization throughout the galaxy. Worlds that have been considered impossible to inhabit could become centers of industrial development. That's the plan, Ambassador. However, Veltar interjected, if your approach fails, you will lose your entire personnel complement. The risk is enormous. Sarah looked around at her team, noting the determined expressions on their faces. Elena was practically vibrating with excitement about the engineering challenges ahead. Michael was already planning geological surveys for the thermal event. Dr. Kim was calculating environmental benefits of the thermal siphon approach. Coordinator, the risk of failure is significant, but the potential benefits of success are even more significant. That's why humans volunteer for missions like this, to prove that extreme environments can be conquered. Zixal asked, No, Commander Sarariplaev, to prove that extreme environments can be improved. As the transmission ended, Sarah turned to address her team. The base around them buzzed with activity as construction crews worked to complete the basic habitat systems before beginning the massive project of installing thermal siphon networks. All right, people, we've got 8 weeks to turn a survival base into a thermal processing facility capable of handling planetary fever conditions. Anyone think we can't do it? Elena raised her hand with a grin. Captain, I think 8 weeks might be too much time. With proper thermal management, we should be able to complete the conversion in 6 weeks and spend the remaining time testing our systems. The crew erupted in laughter and excited conversations about the technical challenges ahead. Sarah watched her team dive into the most ambitious engineering project in human history with the same enthusiasm they'd shown for every other impossible challenge they'd encountered. As construction operations shifted into high gear around her, Sarah reflected on the difference between human ambition and alien caution. The galactic civilizations saw the planetary fever as a catastrophe to be avoided. Humans saw it as an opportunity to be seized. The difference wasn't in their technology or their intelligence. It was in their willingness to turn disasters into advantages. Thermos 7's greatest challenge was about to become humanity's greatest triumph. The planetary fever began exactly as predicted and immediately exceeded every prediction. Captain Sarah Chun stood in the observation dome of Thermos Base Alpha, watching the surface of the planet transform into something that resembled the birth of a star. Through the reinforced transparent aluminum windows, she could see thermal geysers erupting kilometers into the atmosphere, while ice storms raged in areas where the temperature had dropped below what most scientists considered the threshold for matter to exist in normal states. Captain, Elena Vasquez's voice came through the communication system, barely audible over the rumbling vibrations that ran through the base structure. You need to see this. Sarah made her way through corridors that hummed with barely contained energy. The thermal siphon networks were operating at capacity, channeling the incredible thermal forces raging above them into useful power for the base systems. Emergency lighting cast everything in a warm amber glow, while status displays showed power generation levels that exceeded their wildest projections. She found Elena in the central engineering bay, surrounded by holographic displays that showed real-time data from across the thermal siphon network. The engineer's eyes were bright with exhaustion and exhilaration. Elena, please tell me that expression means good news. Captain, it's better than good news. The planetary fever is generating thermal energy at levels we never imagined possible. Our power output is currently running at 2,400% of normal capacity. Sarah blinked at the numbers on the displays. 24 times normal power generation. And climbing. The thermal differential between the surface hot zones and cold zones is creating energy gradients that are off our measurement scales. Dr. James Nakamura looked up from his materials processing station, his face streaked with sweat from working near the thermal processing units. Captain, the manufacturing operations are exceeding all projections. We're processing raw materials faster than we could design new projects for them. How much faster? We've manufactured enough structural components to build 3 more bases the size of this one. The thermal forging processes are converting raw planetary materials into finished goods at industrial scales. Dr. Michael O'Brien's voice crackled through the communication system from his geological monitoring station. Captain, the seismic activity is exposing mineral deposits that we couldn't have reached with conventional mining operations. Rare elements that typically require deep core extraction are being delivered directly to our collection points. Sarah studied the tactical displays showing the base's operational status. Every system was running in the green, despite conditions on the surface that would have been immediately lethal to any unprotected life form. The thermal siphon networks were functioning exactly as Elena had designed them. Not perfectly, but adequately under impossible conditions. Any system failures? Sarah asked. Elena grinned. Plenty. We've lost about 40% of our surface thermal collectors, 15% of our primary thermal conduits, and 30% of our power regulation systems. That sounds like a disaster. It would be if we hadn't planned for 60% system failures. We're actually running better than our worst-case projections. Dr. Sarah Kim joined the group, her environmental monitoring equipment showing atmospheric readings that defied conventional understanding. Captain, the planetary fever is creating weather patterns that are actually stabilizing because of our thermal siphon operations. Stabilizing how? The thermal siphon networks are providing relief valves for the excessive thermal energy. Instead of building up until it explodes into massive storms, the energy is being channeled into our power generation systems. We're literally calming down the planetary fever by giving it somewhere productive to go. The communication console activated, indicating multiple incoming transmissions from the observing alien fleets. Sarah had Marcus put them through on the main display. The hologram revealed a conference of alien representatives that had grown significantly since the planetary fever began. In addition to the familiar faces of Veltar, Zexen, and Zixhull, Sarah counted representatives from at least 6 other species, all displaying various levels of amazement and concern. Captain Chun, Ambassador Klex then spoke for the group, their ethereal form shimmering with what Sarah had learned to recognize as intense curiosity. Our sensors indicate that Thermus Base Alpha is not only surviving the planetary fever, but actually thriving during it. That's correct, Ambassador. Our thermal siphon networks are converting the fever's thermal energy into useful power for base operations and industrial manufacturing. A new voice joined the conversation as Fleet Admiral Cordex materialized in the hologram. The massive, armored form belonged to a species Sarah didn't recognize, but their obvious military bearings suggested they represented one of the major galactic powers. Human Captain, Cordex's translated voice carried undertones of disbelief. Our tactical analysis indicates that your base is generating more power during this catastrophic event than most civilizations produce with their primary industrial facilities. Elena stepped forward with obvious pride. Fleet Admiral, the planetary fever represents one of the most concentrated sources of thermal energy we've ever encountered. We'd be foolish not to harness it for productive purposes. Crystalline entity Zexen's form was displaying color patterns that Sarah's translation system identified as profound technical admiration. Engineer Vasquez, our calculations suggest that your thermal siphon networks are processing thermal energy equivalent to a stellar power source. How is this possible with your technology level? Simple design philosophy, Elena replied. Instead of trying to create perfect thermal management systems, we created adequate systems that work even when most of them fail. But the engineering precision required for thermal siphon networks operating at these energy levels, High Engineer Vexmore protested, his harmonic voice resonating with confusion. Such systems should require computational power and materials science beyond current galactic capabilities. James joined the conversation from his materials processing station. Hi, engineer. Our thermal siphons don't require precision. They require redundancy. We built 10 times as many thermal collection points as we needed, knowing that most of them would fail under extreme conditions. But the inefficiency, Vexmore continued, the waste of resources and energy is irrelevant when you have access to effectively unlimited thermal energy, Sarah replied. The planetary fever provides so much thermal power that we can't afford to be inefficient. Fleet Admiral Cordex was studying tactical displays that showed the base's power output and industrial capacity. Captain Shun, at current production rates, your single base will achieve industrial output equivalent to a major planetary manufacturing center within days. That's our projection as well, Fleet Admiral. How was this strategically possible? Your species lacks the advanced automation and materials science necessary for rapid industrial development. Dr. O'Brien's voice joined the conversation from his geological station. Fleet Admiral, we're not using advanced automation. We're using simple, robust systems that can be easily repaired and replaced. Explain. Our manufacturing operations use basic thermal forging techniques that require minimal technological sophistication. Dr. O'Brien continued. The extreme temperatures from the planetary fever provide all the energy we need to process raw materials into finished goods using relatively simple equipment. Ambassador Klex then was processing this information with obvious fascination. Captain Shun, you're describing an approach to industrial development that bypasses centuries of technological advancement. Instead of developing sophisticated manufacturing systems, you're using environmental energy sources to power simple manufacturing systems. Exactly. Why build complex factories when you can use planetary thermal energy to achieve the same results with simple tools? Coordinator Veltar's gill slits were fluttering rapidly. Captain, this approach seems to violate established principles of industrial efficiency. Advanced civilizations develop sophisticated systems precisely to avoid dependence on unpredictable environmental factors. Elena Lauzet. Coordinator, unpredictable environmental factors aren't a problem if you design systems that work regardless of environmental conditions. Our thermal forges will work whether the planetary fever generates 1,000-degree temperatures or 5,000-degree temperatures. But surely there are limits to this approach. Zixal asked, what happens when the planetary fever ends and you lose access to extreme thermal energy sources? Then we switch to normal power generation systems and continue operations at standard industrial capacity, Sarah replied. The thermal siphon networks will continue to function using regular planetary thermal cycles. We'll just produce goods at normal rates instead of accelerated rates. A new voice joined the conversation as research director Wilamera appeared in the hologram. The spider-like being's multiple optical sensors were focused intently on the human representatives. Captain Shun, our analysis suggests that your approach to extreme environment industrial development could revolutionize colonization strategies throughout the galaxy. Worlds that have been considered uninhabitable could become major industrial centers. That's one of our long-term goals, research director. However, Wilamera continued, this approach requires a species willing to establish colonies in environments that would be immediately lethal to most known life forms. Few species possess the psychological characteristics necessary for such ventures. Dr. Kim stepped forward with a smile. Research director, humans volunteer for missions like this specifically because they're dangerous and challenging. We don't see extreme environments as obstacles to be avoided. We see them as opportunities to be exploited. But the risk factors, Veltar protested. The probability of catastrophic failure, the potential loss of entire colonist populations, are acceptable trade-offs for the potential benefits of success, Sarah finished. Coordinator, human expansion into dangerous environments isn't reckless. It's calculated risk-taking based on our confidence in human adaptability and ingenuity. The alien representatives conferred among themselves for several minutes. When they returned, their expressions showed a mixture of amazement and concern. Captain Shun, Ambassador Klex then spoke for the group. The Galactic Research Council wishes to formally document your methods and results for distribution to member civilizations. Your approach to extreme environment colonization represents a significant advancement in galactic development capabilities. We're happy to share our techniques, Ambassador, with the understanding that they work specifically because they're designed for human operational characteristics. Meaning, Elena stepped forward with her characteristic grin. Meaning that our systems work because humans are willing to accept high failure rates, dangerous working conditions, and technological imprecision in exchange for rapid development and high adaptability. Most galactic civilizations aren't psychologically equipped for our approach. You're saying that your success depends not on superior technology, but on superior tolerance for chaos and uncertainty? Research Director Wylamera asked. Exactly, Sarah confirmed. We succeed in extreme environments because we're comfortable with things going wrong and having to fix them constantly. As the transmission ended, Sarah turned to survey her team. The engineering bay buzzed with activity as specialists monitored thermal siphon operations, managed manufacturing processes, and coordinated base expansion projects. Despite working under conditions that would be considered catastrophic by galactic standards, every human in the base was displaying the calm competence that came from turning impossible challenges into routine problems. Status report, people. How are we handling our first planetary fever? Elena consulted her engineering displays. Power generation holding steady at 2,300% normal capacity. Manufacturing operations producing finished goods at industrial scales. Base expansion ahead of schedule. James looked up from his materials processing station. Captain, we've processed enough raw materials to supply a small fleet. Our storage facilities are reaching capacity. Dr. O'Brien's voice came through the communication system. Geological surveys showing continued exposure of valuable mineral deposits. We could establish mining operations that would supply the entire sector. Dr. Kim added her environmental assessment. Atmospheric conditions stabilizing due to thermal siphon operations. Local weather patterns becoming more predictable and less destructive. Sarah nodded with satisfaction. Around them, Thermos Base Alpha hummed with the controlled chaos that characterized human operations under impossible conditions. Thermal energy flowed through siphon networks that should have failed catastrophically. Manufacturing systems produced goods using techniques that violated every principle of efficient industrial design. Environmental conditions that had driven 3 major galactic civilizations away from the planet were being harnessed to power humanity's most ambitious colonization project. All right, people. We've got 8 more days of planetary fever to work with. Let's see how much we can accomplish before things get back to normal. Elena raised her hand with excitement. Captain, I've been working on designs for thermal collection systems that could harness the energy from stellar flares. If this approach works on Thermos 7, Sarah grinned as she watched her engineer's mind already racing ahead to even more impossible challenges. Elena, let's finish conquering this planet before we start planning to harness stars. Yes, ma'am. But I'm definitely putting stellar thermal collection in my project notes. As the planetary fever continued to rage above them, Thermos Base Alpha stood as proof that humanity's greatest strength wasn't their technology or their intelligence. It was their willingness to look at the impossible and ask, what if we tried anyway? The lesson was almost complete. 2 weeks after the planetary fever ended, Thermos Base Alpha had become something that no one, human or alien, had ever imagined possible. Captain Sarah Chun stood on a newly constructed observation platform that extended above the planet's surface, watching the sunrise paint the transformed landscape in shades of gold and crimson. Where once there had been barren rocks subjected to impossible thermal extremes, now there were terrace gardens using geothermal heating, manufacturing complexes that hummed with quiet efficiency, and research stations that monitored the planet's gradually stabilizing climate patterns. The base itself had grown from a survival shelter into a small city. Thermal siphon networks snaked across the landscape like technological rivers, channeling the planet's natural thermal energy into a vast power grid that supplied not only the human colony, but also research stations that had been established by 5 different alien species who had returned to study humanity's approach to extreme environment colonization. Captain, Elena Vasquez approached with a tablet displaying the daily operational reports, her face showing the satisfied exhaustion that came from successfully completing the most challenging engineering project of their careers. Final systems analysis from the planetary fever period. Let me hear it, Elena. Total power generation during the 14-day fever period exceeded our most optimistic projections by 400%. Manufacturing output reached levels equivalent to a major industrial world. We produced enough processed materials to supply colony development throughout this entire sector. Dr. James Nakamura joined them on the platform, his materials analysis equipment showing readings that still seemed impossible even after experiencing them firsthand. Captain, the thermal forging processes we developed during the fever are continuing to work with normal thermal cycles. We've essentially established permanent industrial capabilities using the planet's natural energy sources. Production capacity? Sufficient to supply 3 additional colonies of this size, with expansion potential as we develop more sophisticated thermal collection networks. Dr. Michael O'Brien emerged from the underground geological monitoring station, his Irish accent thick with the excitement of discovery. Captain, the long-term geological effects of our thermal siphon operations are remarkable. Instead of destabilizing the planet's thermal patterns, we've actually helped stabilize them. Sarah raised an eyebrow. Explain. The thermal siphon networks provide consistent pressure relief for the planet's internal thermal system. Instead of building up to explosive release during fever periods, the thermal energy now has continuous outlets through our power generation systems. Dr. Sarah Kim approached with environmental monitoring data that showed atmospheric readings that would have seemed like science fiction just months ago. Captain, the planetary climate is stabilizing at levels that could support standard human habitation within a year. We've essentially helped Thermos 7 regulate its own temperature extremes. You're telling me we've made the planet more habitable just by living here? That's exactly what I'm telling you. The thermal siphon networks function as a global thermal regulation system. We're not just surviving in an extreme environment. We're helping to moderate the extremes. The communication console activated, indicating an incoming transmission that Sarah had been expecting. She activated the holographic display, which revealed a conference room filled with representatives from every major galactic civilization, along with several species that Sarah had never encountered before. Ambassador Klex then materialized first, their ethereal form radiating what Sarah had learned to recognize as profound respect. Captain Chun, the Galactic Research Council has completed our analysis of the Thermos 7 colonization project. What are your conclusions, Ambassador? That humanity has achieved something unprecedented in galactic history. You have not only successfully colonized an environment previously considered impossible for life, but you have actually improved that environment through the colonization process. Coordinator Veltar appeared next, his gill slits fluttering with what Sarah now recognized as amazement rather than distress. Captain Chun, Zephyrian Atmospheric Specialist, have reviewed your thermal siphon designs. We would like permission to adapt your techniques for our own extreme environment projects. Granted, Coordinator, with the understanding that our techniques are specifically designed for human operational characteristics. Crystalline entity Zexon's form displayed color patterns indicating deep appreciation. Engineer Vasquez. Nexury Crystal Engineers wish to establish collaborative research programs to study your thermal management approaches. Your integration of simple technology with extreme environmental conditions represents a paradigm shift in engineering philosophy. Elena stepped forward with obvious pleasure. High Entity, we would be honored to share our techniques. However, I should warn you that our methods deliberately sacrifice efficiency for reliability. We have observed this characteristic, Zexon replied. It appears that reliability under extreme conditions is more valuable than efficiency under optimal conditions. Commander Zixhull joined the conversation, his mechanical precision unable to hide what Sarah suspected was the cybernetic equivalent of admiration. Captain Chun, Vorthack Tactical Analysis suggests that human extreme environment colonization techniques could revolutionize galactic expansion strategies. Worlds previously considered uninhabitable could become centers of industrial development. That's our long-term goal, Commander. A new voice joined the conversation as Supreme Researcher NAL Corvex materialized in hologram. The imposing figure belonged to a species that Sarah didn't recognize, but their obvious authority suggested they represented one of the galaxy's most advanced civilizations. Human Captain, NAL Corvex's voice carried undertones of something that Sarah's translation system identified as profound intellectual curiosity. Our analysis indicates that your species possesses unique psychological characteristics that enable success in environments where more advanced species fail. What characteristics specifically, Supreme Researcher? Tolerance for imperfection, acceptance of high failure rates, and willingness to use simple solutions for complex problems. Most galactic civilizations develop sophisticated technologies to avoid these characteristics. Humans embrace them as operational advantages. Dr. O'Brien joined the conversation from his geological station. Supreme Researcher, we don't see imperfection and failure as problems to be eliminated. We see them as normal operational conditions that need to be managed. Elaborate. Elena stepped forward with her characteristic enthusiasm. Supreme Researcher, galactic civilizations try to create perfect systems that work correctly under ideal conditions. Humans create adequate systems that continue working when everything goes wrong. But surely there are limitations to this approach. NAL Corvex pressed. What happens when human systems encounter conditions that exceed even your tolerance for imperfection? Sarah looked around at her team, noting the confident expressions on their faces. They had just completed a project that every galactic civilization had declared impossible, using techniques that violated every principle of advanced engineering, in an environment that should have killed them all within hours. Supreme Researcher, when our systems encounter conditions that exceed our design parameters, we redesign our systems. Human technology is meant to be modified, improved, and replaced as needed. You don't try to create permanent solutions. There are no permanent solutions, James replied from his material station. Everything breaks eventually. The key is building things that are easy to fix when they break. Fleet Admiral Cordex appeared in the hologram, his massive armored form displaying what Sarah had learned to recognize as military respect. Captain Shun, our strategic analysis indicates that human extreme environment colonization capabilities represent a significant tactical advantage in galactic development. How so, Fleet Admiral? Worlds that other civilizations cannot inhabit become centers of human industrial development. Planets that serve as barriers to conventional expansion become stepping stones for human expansion. Research Director Wilamera joined the conversation. Her multiple optical sensors focused intently on the human representatives. Captain Shun, our xenopsychological analysis suggests that human success in extreme environments results from fundamental differences in risk assessment and problem-solving approaches. Explain. Most galactic species assess risk by calculating the probability of catastrophic failure and designing systems to eliminate that probability. Humans assess risk by calculating the consequences of catastrophic failure and designing systems to manage those consequences. Dr. Kim stepped forward with a smile. Research Director, we don't try to prevent things from going wrong. We assume things will go wrong and plan accordingly. This approach seems to contradict basic principles of technological advancement, NAL Corvex observed. It does, Sarah agreed cheerfully. Advanced technology focuses on preventing problems. Human technology focuses on solving problems after they occur. Ambassador Klex then was processing this information with obvious fascination. Captain Shun, the Galactic Research Council wishes to establish permanent collaborative research programs to study human extreme environment techniques. Your approaches could enable colonization of worlds throughout the galaxy that have been considered uninhabitable. We're happy to collaborate, Ambassador, with the understanding that our techniques work specifically because they're designed for human psychological and operational characteristics, meaning that other species might not be able to effectively utilize human methods. Elena Grinet. Ambassador, our methods work because humans are comfortable with constant equipment failures, dangerous working conditions, and having to improvise solutions using whatever materials happen to be available. Most galactic species aren't psychologically equipped for that level of operational chaos. But surely, Veltar protested, advanced civilizations could adapt human techniques for their own use with appropriate technological modifications. You could try, James replied diplomatically, but you'd probably end up making our simple systems so sophisticated that they'd stop working under extreme conditions. The alien representatives conferred among themselves for an extended period. When they returned, their expressions showed a mixture of respect and bewilderment. Captain Shun, Ambassador Klexton spoke for the group. The Galactic Research Council hereby formally recognizes humanity as the galaxy's foremost experts in extreme environment colonization. We request that Earth establish training programs to teach human techniques to interested galactic civilizations. Granted, with the standard warnings about human operational requirements. As the transmission ended, Sarah turned to survey the transformed landscape around Thermos Base Alpha. The planet that had driven 3 advanced civilizations away in defeat was now home to a thriving human colony that served as a demonstration of humanity's unique approach to impossible challenges. Status report, people. How does our impossible planet look today? Elena consulted her engineering displays with obvious satisfaction. Thermal siphon networks operating at optimal efficiency. Power generation sufficient for current operations with capacity for significant expansion. Manufacturing facilities producing goods for export to other colonies. James looked up from his material station with pride. Industrial output exceeding projections. We're producing finished goods at rates that would require major industrial facilities using conventional approaches. Dr. O'Brien's voice carried the excitement of ongoing discovery. Geological stability improving daily. The thermal regulation effects of our siphon networks are helping the planet find natural equilibrium. Dr. Kim added her environmental assessment with obvious pleasure. Atmospheric conditions approaching standard human habitability parameters. Local weather patterns becoming predictable and manageable. Sarah nodded with deep satisfaction as she watched the sunrise illuminate a landscape that represented humanity's greatest triumph over impossible odds. Around them, the base hummed with the quiet efficiency that came from turning catastrophic environmental conditions into routine operational advantages. All right, people, we've successfully colonized an impossible planet, established industrial capabilities that exceed galactic standards, and accidentally improved planetary climate stability. What's our next project? Elena raised her hand with barely contained excitement. Captain, I've been analyzing stellar thermal output patterns. I think we could apply our thermal siphon approach to harness energy directly from solar flares. Dr. O'Brien joined the conversation with equal enthusiasm. And I've identified 3 other planets in this sector with extreme environmental conditions that could be turned into industrial development opportunities. Dr. Kim added her own suggestions. The atmospheric modification techniques we developed here could be used to improve environmental conditions on marginal worlds throughout human space. James looked up from his material station with the expression that meant he had been thinking about engineering challenges again. Captain, with the industrial capacity we've developed here, we could supply the materials for major expansion projects throughout this entire sector. Sarah looked around at her team, noting the eager expressions and excited conversations about even more impossible challenges ahead. She reflected on the difference between human ambition and galactic caution that had made this project possible. Other species had looked at Thermos 7 and seen an impossible environment that should be avoided. Humans had looked at the same planet and seen an opportunity to prove that impossible was just another war.